Welcome to Module 7, Lesson 1, Writing and Solving One-Step Inequalities. Today we're going to talk about how to interpret the solution of an inequality in the context of a problem. So not just solving it, but then what does that answer actually mean? And then how to solve word problems that lead to inequalities. And then in doing so, we're also going to touch base on some standards that we've already touched base on before. In constructing simple equations, using variables to represent quantities in real-world problems, and solving simple equations. So now remember, we've talked about this previously, but when we're solving inequalities, it's just like solving an equation. So before, when we were doing x plus 3 equals 4, an equation gets solved the same way an inequality does. So don't let the fact that now there's this inequality symbol fool you. They get solved the same way. We still subtract 3, subtract 3, subtract 3, subtract 3. But now we have x is greater than or equal to 1, whereas here we have x is equal to 1. And we're going to talk about how these two things are different. Before we get into that, though, I need you to go to example 1a, and I need you to draw in a number line. Now this number line for 1a, so quickly go with me and write this down. Don't draw the number line yet. For a, it can be from 0 to negative 20. So remember, negative 20 should be down here. Then you need to do one for 1b. For 1b, yours can be from 0 to positive 20. Write that down, okay? Then you need to go to example 2a. Example 2a, your number line can be from 0 to 20. And then again, you're going to need one for 2b, and in 2b, yours can be from 0 to negative 20. All right, so I want you to pause and draw in those number lines, and then go back to the front, and when you're done, we'll go ahead and get started. All right, so now that you've drawn in your number lines, we're going to go ahead and take a look at what happens to our inequalities when we add numbers to both sides. So just to take a look and make sure everything works out okay, we're going to add 3 to both sides and see what happens. See if our inequality is still true after we do that. Because we said the golden rule in math is what you do to one side, you do to the other, and it should be okay. So let's test that out. So here, if I add 3 to both sides, I get 5, and that should be greater than or equal to 0. Is that still true? Absolutely. 5 is absolutely still greater than 0. Let's add negative 1 to both sides. I get negative 2, and it should be less than or equal to 5, and that is absolutely still true. Here, if I add negative 8 and negative 8, I get negative 16. And that should be greater than negative 8 plus negative 10, which is negative 18. And that is also still true. So when I add the same number to both sides of an inequality, is the inequality still true? Absolutely, it's still true. It's that rule in math. What you do to one side, you do to the other. And that should leave everything balanced. That always works when it comes to addition. And so should it work with subtraction? Absolutely, because you're doing the same thing but in the opposite direction. So absolutely it should still work. So our answer here is yes. And yes, it is true for subtraction because you are doing the same thing, but in the opposite direction. So it's the same, the concept is the same. You're moving up or left, you're moving up or down or left or right, and you're doing it to both sides. So since you're doing it to both sides, the inequality is still going to hold true. All right? So then let's take a look at division. Let's divide both sides by 4. Well, we have 1, and it should be less than 2. Still holding on here, still true. Well, 12 divided by 3 is 4, and that needs to be greater than or equal to negative 15 divided by 3 is negative 5. Is 4 greater than or equal to negative 5? It sure is. Now we have negative 16 and we're dividing it by negative 4. Well, that gives me a positive 4. And that is supposed to be less than or equal to 12 divided by negative 4, which is negative 3. 4 is less than or equal to negative 3. Well, at this point, you should be going, hold on, Katie, this doesn't work. You're right, this is false. But let's double check. Let's take a look with another negative number and see what happens here. So here I have 15 divided by negative 5, and I get negative 3. And that should be greater than 5 divided by negative 5, which is negative 1. Well, in the negative world, the further away you are from 0, the smaller the number. So once again, this has become false. So we should notice that every time that we divide by a negative number in answer to our question here, our inequality becomes false. So the inequality is no longer true. So this presents a problem because we said that solving inequalities is the same thing as solving an equation. And what you do to one side, you have to do to the other. But these negative numbers kind of screw things up a little bit for us. So if that's the case, what are we going to do? Well, take a look at your inequalities here. These two that are a little bit mixed up. What could I do to make those work? Is there an easy fix to that? Well, if you said, Katie, why don't you just flip the sign? You're right. It is as simple as that. Just flip the sign. You can literally flip the inequality sign. So what we do when we divide by a negative number is after we do so, we flip the inequality symbol. And in doing that, it makes the inequality true and it makes everything work. All right? So now we have to look and say, all right, well, if that's the case with division, does that have to be the case with multiplication? Look at your multiplication rules for integers. When you multiply by a negative number, it's going to change the sign. So the rules are the same. Since the rules are the same, it's going to act the same when it comes to an inequality. So yeah, it's going to work for multiplication too. So that same argument that we made for addition and subtraction, we can make for multiplication. So since the rules for multiplying and dividing integers are the same, and multiplying a number is the same as dividing a number by its reciprocal, this will hold true for multiplication. All right. So since the rules are the same for integer multiplication and division, and since multiplying is the same thing as dividing by the reciprocal, this will work. So let's test our theory right now when it comes to addition and subtraction. And then we're also going to talk about how do we graph the solution. So first and foremost, let's take a look at what it looks like when we have to graph our numbers. I always graph my stuff in red because it makes it easier to read on the number line. You have to use a closed dot when you have less than or equal to and greater than or equal to. That shows that because it says equal to, that shows that you can include that number in the solution set. You have to use an open dot for less than and greater than, because that shows that you cannot include that number in the solution set. So what that means is your solution set is any set of numbers that will make your inequality true. All right, so like if I said k is greater than 2, any number bigger than 2 can be a part of the solution set. So 3, 4, 5, 6, 7, 2.5, 2 3/4. Those are all numbers that could be a part of my solution set. Okay, but since 2 is not greater than 2, it is not included, so I would have to use an open dot when graphing it on a number line. Let's take a look at what I mean after solving this inequality. So let's solve this just like we would an equation. It's addition, and we're adding the 5 to the x, so we're going to subtract 5 from both sides. We're left with x on the left is less than negative 17. So what this tells me is, in my solution set, any number that is less than 17 should make this statement true. So any number that I substitute for x that's less than 17 should work. Let's double check. Negative 18. In the negative world, it has to be further away from 0. Negative 18 is further from 0, so let's plug it in for x and see if my inequality is still true. Negative 18 plus 5 gives me a negative 13, and negative 13 is less than negative 12. So I know that I did this correctly. So let's go ahead and graph it. So now when I'm graphing, again, I'm going to use red. I look and I plot my point at negative 17. This one has to be an open dot because negative 17 cannot be included in my solution set. X is less than negative 17. So that means every single number on this number line that is smaller than negative 17 will work in this inequality. And that's all that you have to do to graph your solution set. Let's go ahead and try example B. All right, so here we're subtracting on both sides, and we have y minus 3. So we have to add 3 to both sides. So I have 11 is greater than or equal to y. Okay, so now here's what's confusing. 11, I'm sorry, not greater than or equal to, less than or equal to. 11 is less than or equal to y. So the 11 is less than or equal to y, which means y has to be bigger than 11. So that means it has to be this way of 11 on the number line. This is really confusing, especially when you're just starting out with inequalities. If you're struggling, your goal is going to be to get the inequality on the other, the variable on the other side. To do that, though, you have to write the variable and then you have to flip your symbol. So y is greater than 11. All right, so it's greater than or equal to, so now I'm going to plot my point. In this case, it's 11, and it's a closed dot because it can include 11. So y is greater than or equal to 11. It's all numbers 11 and larger. So I draw my line on all the numbers that are larger than 11, and then I draw an arrow because there's still more numbers that are available past 20. Now again, let's double check. Let's pick a number that's larger than 11 and see if it works. Typically, I would just pick the next number just because you want to stick close to make sure that you didn't make a mistake. All right, so in this case, I'm going to choose 12 and see if 8 ends up being less than or equal to 12 minus 3. So 8 is less than or equal to 12 minus 3 is 9. Is 8 less than or equal to 9? That is absolutely the case, so I know that I did this correctly. All right, now it's your turn. So it's your turn to solve. And once you solve, you are going to also graph your points. Okay? If you want to solve first before you graph and come back and check, I will be showing the answer to the inequality first and then graphing it. And then you can come back and then you can graph it and then come back and check your graph. So your choice, you can either do it all or part and part, it's up to you. But when you come back, we'll check your answer. All right, so you should have come up with y is greater than or equal to -2. All right, because you add 5 to both sides. So y is greater than or equal to -2. And then here for number 5, you should have ended up with x is less than 9 because you have to subtract 12 from both sides. So you end up with 9 is greater than x, and then you can rewrite that as x is less than 9. Either way will work. Again, this is the easier way to write it because it makes it easier to graph. Okay, and if you didn't graph yet, go ahead and pause, and when you come back, you can check your answer for graphing. All right, so to graph the first one, we need a closed dot because it can include the number, and the closed dot goes on -2. And in this case, y is greater than -2, so the arrow is going to point to the left. And I always make it go all the way through the line. It just makes it look neater. So it should look like this. For the second one, you should have an open dot because it cannot include the 9. And x has to be less than 9, so your arrow should actually be pointing to the left. All right, so here we go. Now we're going to work on some multiplication and division inequalities. So this is where the flipping of the sign comes in. But remember, only flip if you multiply or divide. So only flip when multiply or divide by a negative. Okay, so let's take a look. In this case, now if you're confused by the y over 3, you can rewrite it. And remember, this is y divided by 3 is greater than or equal to 5. Now, I'm going to multiply both sides by 3. I am multiplying, but by a positive 3. So I do not have to flip my sign. So this becomes y, my sign stays the same, is greater than or equal to 15. Okay, again, I can check my solution set by, let's put in 16. Okay, and we can do, actually, why would we do 16 when 16 would give us a fraction? Let's put in 18. So let's put in 18, and we're going to divide it by 3, and it should be greater than or equal to 5. 18 divided by 3 is 6, which is greater than or equal to 5, so we know that we did it correctly. It's a greater than or equal to symbol, so I know it's a closed dot on 15. It's greater than or equal to, so it's going to point to the left, and then I draw my arrow. I'm sorry, point to the right. I don't know my directions today. Point to the right. So now we have -4x, and that is greater than, -4x is greater than 52. So now we are going to divide both sides by a -4. And that rule was if we divide by a negative, so I'm dividing, and that number I'm dividing by is a negative. So this number that I'm doing to both sides with is negative. So I do have to flip my sign. So do I have to flip? Yes. So I know that x is going to be by itself. I have to flip my sign. And I know that 52 divided by -4 is going to be a -13. So when I realize that my sign has been changed, that should be your clue that your inequality symbol should have been flipped. So when the sign of your number changes, your inequality symbol should have been flipped. So again, let's double check our work. And x has to be less than negative 13. Less than. Can't be equal to, has to be less than. So let's try negative 14. So negative 4 times negative 14. Well, 4 times 10 is 40, and 4 times 4 is 16. 16 plus 40 is 56. Negative plus times a negative is a positive, so I get 56. So I know, so is this greater than, so again, I have to put it back into my original because it's negative 4 times x is greater than 52. Okay, so here, what I want to see is negative 4 times negative 14, is it greater than 52? This is what I got, that negative 4 times negative 14 is 56. So 56, is it greater than 52? Yes, it is. So I know that this is true. So I know I did right. Okay, so let's go ahead and plot. I know I have to plot at negative 13. It's an open dot because it cannot include, because it's only a less than sign. My numbers have to be smaller than 13, so it is going to point to the left this time because it's less than, so less than and left. Yes, I know it's actually the left this time. I do know my left from my right, I promise. Most days. All right? And so my inequality has now been graphed. It's been checked. I know it is correct. So let's go ahead and let's check on the next one. So here you have two problems. What I'd like you to do is, again, I'd like you to try them, come back and check your answer, and then graph it and come back and check your answer. So for this one, you should have gotten that y is equal to, y is greater than negative 6, and that t is greater than or equal to negative 42. Okay, now remember, so negative 10 times y is less than 60. You're dividing by negative 10. So when I do that, my answer here became a negative 6, which tells me my sign should be flipped. Okay, then here I had 7 is greater than or equal to t divided by 6. So I'm multiplying both sides by 6. My sign stayed the same, so no need to flip, so I'm good. All right, so then now what you can do is you can graph, and when you come back, we'll check your answer. All right, so here you should have found that you had to have an open dot on your 6 because it could not include the 6. Y is greater than negative 6, so it should be pointing to the right. And it should include all the numbers that are greater than negative 6. On the next one, it should be a closed dot because it could include negative 42. Since it could include negative 42, excuse me, that closed dot goes on negative 42, and since it is greater than negative 42, it has to point to the right. Right. One more problem here, and then we are good to go. So now we're going to take a word problem, and from that word problem, we're going to create an inequality, and then we're going to solve it. All right. So I have a marine submersible descends more than 40 feet below sea level. As it descends from sea level, the change is -5 feet per second. For how many seconds does it descend? So I have to highlight the question. For how many seconds does it descend? And let's look for some important words here. Okay, we talked about this in class. So descends more than, and it's 40 feet, and it's below sea level, so that's probably important. It's a -5 feet per second. Okay, so let's take a look at what that tells me. So setting up this problem, I know that it goes -5 feet per second. So it's dropping -5 feet per second. So -5 feet per second, which is more than 40 feet below sea level. Okay? More than implies the greater than symbol. And it implies the greater than symbol because it can't be equal to, because it says more than. So it can't be greater than or equal to because it straight up says it has to be more than that. All right? So what it's asking you is how many seconds did it descend for if it went -5 feet per second and it went more than 40 feet? How many seconds did it have to go for? We're not asking how far did it go, but how many seconds did it have to go for in order to go more than 40 feet? So we're going to divide both sides by -5. Divide by -5. So t, and then I have -40 divided by -5 is 8. So my sign has to flip. So the time has to be greater than 8 seconds. Okay, so what this means is, that doesn't mean that it descended for 8 seconds. What this means is the marine submersible descends for more than 8 seconds. Okay? Now, that doesn't mean that, so it doesn't descend for 8 seconds exactly. It's telling you it has to go for more than 8 seconds because it has to go for more than 40 feet. So could it descend for 9? Yes. 10? Yes. 7? No. That more than changes this from an equation to an inequality. So you have to read carefully in these problems. So taking a look at this, every month, $35 is withdrawn from Tony's savings account to pay for his gym membership. He has enough savings to withdraw no more than $315. For how many months can Tony pay for his gym membership? Okay, so that no more than is really important. No more than. So no more than, what would that imply? Can it be bigger than this? The answer is no. So since it can't be bigger, it has to be smaller. So it has to be, so when it comes to 315, it has to be less than 315. So no more than would go on your less than in your words section in your foldable. So less than, whatever he does has to be less than $315. Okay, could it be $315? So no more than. Yes, it could. Okay, no more than that though. So could it be 315? Yes, but can it go higher than that? No. So I'm sorry, not your less than, your less than or equal to section. So more than would be your less than, No more than would be your less than or equal to. That little word no makes a huge difference. So every month, $35 is withdrawn from Tony's savings account. Do we care that it's for his gym membership? No. But withdrawn tells us that it's negative. Each month tells us that we're going to multiply by m. So negative 35m is less than or equal to 315. So then what I'm going to do is I am going to divide no more than implies that what they take out cannot be any bigger than. So it should be greater than or equal to. My goodness. I was looking at the wrong problem. So no more than. See how tricky this can be? So no more than. So he can take out $315, okay? But he can't take out anything more than that, okay? That's it. So whatever he takes out has to be outside of that 300, and this is where it gets crazy because it's a negative 350, or it's a negative 35, and this withdraw is a negative 315. So in this case, because it's a negative, this has to be greater than the negative 315. Even though no more than would technically, yes, it would give us the less than or equal to. In this case, it's going to give us the greater than or equal to, okay? So here, we're going to divide both sides by negative 35. Here, we're left with m. Negative and a negative gives me a positive 9, so I know my sign has to be flipped. So he cannot take out for more than 9 months. Okay, so he can pay for no more than 9 months of his gym membership using his account. I know this one is complicated. Obviously, it's complicated. I got jazzed up when I was reading it. This is why we want to slow down, and you don't want to try to do 2 things at once. The negative is what threw us off here. It's what threw me off. Since it's being withdrawn, that's where the problem is. If we were to look at it just as a regular problem, so, he's taking out $35 per month, and that can be no more than. So that has to be less than or equal to 315. That I would have completely accepted. That was where my mind went. When you throw the negatives in, that's when this changes. This makes sense in my mind when it comes to the verbiage. So no more than would be the less than or equal to sign. And you divide both sides by 35, divide by 35. M can be less than or equal to 9. All right? I'm completely comfortable if we stick here. If this is confusing you, I'm cool if you're just like, Katie, let's take that break. Let's focus on this, okay? As always, you're going to do your guided practice, but you're going to do your guided practice on Go Math this time. And then if you have more questions or you want more practice, you can do the guided practice that's in your notes. As always, if you have any questions, please be sure to email me or write them down so we can go over